welcome everybody. We'll jump into some geolocation post-afternoon tea. Now, this is my first time actually presenting at TechEd New Zealand. I'm an Australian speaker and I've presented there for a number of years. And some of the other Australian speakers have warned me about the New Zealand audiences, saying that you always score worse. So hopefully we can be friends. There'll be no bad jokes. I'll try and skip over those. Yeah. So the purpose of today's talk is on a couple of different levels. It's been tagged as Windows Client, it's been tagged as Windows Phone, and it's also in the web track. So you're probably a little bit confused about what exactly I'm going to cover. Geolocation, as developers, we think about latitudes and longitudes. Quite simple numbers, that's how we think as developers. There's a lot more to it than that. So what I'm going to cover is a number of the APIs as far as how can you gather this information across lots of different platforms. And then I'm also going to look at how can we actually make this information useful? How can we build some compelling experiences around it? So to kick off, this is fairly simple. We've got a latitude and a longitude. Can anybody actually tell me where that is? So I'm getting a lot of people saying here. I'm getting a few people say Sydney. Wellington? Oh, close. You're the closest it gets. That's actually Dunedin. Sorry, no, it's not. You're right. It's Wellington. Dunedin comes later in the talk. Okay, talk failure number 1. Who's counting? So one person got it right. But as developers, we get a latitude, longitude from a GPS, and we think, yep, tick, our application has geolocation data in it. But users don't think that way. Users think in terms of Wellington. So the first thing that we identify here is a difference between what's geodetic information, so the numbers, and what's the civic information. The other thing about location is that it likes to move. So users go and change over time. They're in a car or on a train or something like that. So this gives us a sense of heading and speed. We also have an idea of elevation. How far above sea level are they? And we can also go and get the orientation, because just because they're on a train that's heading north, they might be sitting sideways and facing east and looking at something different. When you start to get into things like augmented reality, where you want to be able to hold up a device, use the camera and overlay other information on top of it, you need to worry about the orientation as well. So we end up with these 5 key components: position, elevation, heading, speed, and orientation. Each of these have some form of geodetic representation. So latitude, longitude. I'm 6 meters above sea level. I'm heading at 301 degrees, northwest. A speed, and then also the orientation. But then we have civic representations of this. So I'm in Wellington. I'm on the 2nd floor. Particularly if you start to think about stuff like emergency services, they don't want to know that you're 6 meters above ground level. They need to know that you're on the 2nd floor of the building. I might be on a train heading towards the city, or I might be driving, and I might be sitting sideways on that train facing the bay. So the way that we translate between these two different structures of geodetic and civic is using geocoding, which is where we take civic and turn it into geodetic, or reverse geocoding, which is where we can go and take these latitudes and longitudes and other information and turn them back into something that's civic, that a user can use. So how do we actually go and gather this information? GPS is the most obvious one, but it's kind of expensive in terms of hardware and battery and time. GPS, traditionally, you need to talk to at least 4 satellites. You need to maintain that connection for 40 seconds. And if you don't have all the ephemeral data of what satellites are currently where, it can actually take up to a good 5 minutes to initialize that. Now, if I'm standing on a street corner somewhere and I just want to know where the nearest subway is, do I need to turn left or right? That's not going to help me. So the first thing that we're starting to see in mobile devices is a GPS. So users, you talk about it, my device has GPS. No, it doesn't. It's probably got a GPS, which is assisted GPS. So what this does is it gets all the ephemeral data downloaded from the network. So it'll pull that from Telecom or Vodafone or whoever you're with so that it can get a fast start. And it's a lot cheaper to do that. The other one is just basic cell ID. Remember all the old Nokia phones that used to tell you sort of what suburb you're in? That was just showing the name of the cell. Every single cell also has a unique numeric identifier as well that we can use. And using a number of cells, you can do basic triangulation to work out where a user is, even without GPS. Wi-Fi, same sort of thing. Google got in a lot of hot water over this recently, about 6 months ago, with all their Street View cars driving around. They were also capturing all the Wi-Fi signatures as they drove around. They accidentally, though, captured a whole bunch of packet data, or the payload out of the packets for all the unsecured wireless networks and recorded that information. And there was something like 16 European governments wrote to them and said, we're about to sue you if you don't fix that very, very quickly. But they aren't the only people who have this data, and there are a number of other companies out there who provide this. The other interesting one is the network. Now, this is starting to get, it hasn't really picked up yet, but there are some standards in place which is going to make this really cool. If you think about VoIP, one of the biggest restrictions at the moment to VoIP adoption is emergency service calling. So the ability for you to pick up the phone and dial 000 and have that get routed to the appropriate centre, and also then have them know where you are so they can come and help you, even if you can't tell them the location. Now with VoIP-based services, that starts to get really hard. We don't have any way of actually gathering that information in most devices. Now you can think, well, why can't we just go and shove a GPS chip in every VoIP phone on all the desks? Now we could do that, but you've got a whole bunch of other devices as well. Like, what about my laptop? If I'm making a call from a soft phone on my laptop, how do we get that data? And the person who knows where you are is your internet service provider. Say you're sitting at home, you're on your ADSL, your ISP knows where that ADSL trunk is connected to. So there are actually standards in play at the moment under a group called GeoPriv, the Internet Engineering Task Force, so that your network can negotiate, or your laptop can negotiate with the ISP and get that data and actually get the civic address of where exactly that internet connection is. Obviously, a whole bunch of privacy concerns need to be managed around that. And then the final one is just static. Ask the user where they are. Where are you? Enter your address, enter your suburb, whatever. Because not all of these will necessarily be available, other mechanisms of gathering location. If they are available, they may not be accurate. And even if they are available, particularly the more accurate they get, the more costly they are for you to get that data. The more battery power they use, the longer they take. All right, so now that we've gone through all the concepts and everybody's nice and a little bit bored after all the cheesecake settling in, let's just jump into some code. I'm going to go through a few different scenarios here today. The first one I'm going to look at is how can we actually go and gather location via JavaScript in the browser through our web applications? And what are some of the considerations we need to make there in terms of user interface? I'm also then going to look at Windows 7, so this is your sort of rich client operating system type experience. And then we'll also do some code demos on Windows Phone 7. So it doesn't really matter which platform you're developing on, you'll get a little bit out of each of them, and we will get through all of them. Oop. So the first thing I'm going to do is I'm using Visual Studio as my code editor. However, all of the code that I'm going to write today is completely, well, in this demo, sorry, is completely client-side code. I just use Visual Studio because I think it's a really good editor for building web pages in. And you'll see how that actually helps us today. So what I've got here is a little stub page, and all it has is a link there to find the nearest store. The first thing you might notice on line 1 is the doc type. This is an HTML5 doc type. Doc types are used to go and trigger the browser into a standards-based rendering mode instead of a quirks-based rendering mode. So you have to use one of these if you basically anything you're building these days. Old ones are really long and ugly. HTML5 is nice and short, so you can actually remember it. Then all I've got is a link, and at the moment this just goes to Bing and searches for a pizza shop. And I've got a UL there where I'm going to write some status updates into. Now the first thing I want to go and do is get a reference to jQuery, because nobody writes JavaScript anymore, do they? You write jQuery. And a little tip, so this is digressing slightly from geolocation. If you jump onto jQuery.com through the High Performance Conference Internet, this is where the benefit of sort of CDN and cloud-hosted JavaScript really comes into play when you can actually get to the library. It's now spiting me for that quip about nobody writes JavaScript, and it's going to actually make me write JavaScript shortly. All right. So that's talk failure number 2, if anybody's counting. There we go, and the Wi-Fi seems to be working. Except jQuery.com goes to the hotel internet. No, it says I'm successfully connected. It's not asking me for a wireless password. What I'm going to do is actually close and restart the browser, because the hack that they do to make all this hotel internet work is they dodge up the DNS. There we go, it's cached bad DNS. So if we jump onto jQuery.com, if you hit the massive download jQuery link that's there, it'll give you the file. But what you can actually do, if you go to the download link up in the menu, you'll see the latest version here, the current release, 1.4.2. I'm actually going to go back a version because you'll see next to 1.4.1 there's a little Visual Studio documentation link. Now, I don't need to download that at all, but if I copy the link to the minified jQuery and then just in the end of my body, text JavaScript, I'll put that into the source. What Visual Studio does in the background is not only does it download that file, this is why I like to use Visual Studio as my editor, it's also downloading the VS-Doc file. So now when I go $bracket, I get full IntelliSense for all my jQuery. So little side tip that a lot of people don't know about necessarily. That's currently not available for the latest version, 1.4.2, because I have to manually publish the documentation, but it's getting faster and faster every release. So back onto the geo front. All right, so being a good web developer, the first thing I've got is I'm just going to keep that static link there because the user may not even have JavaScript. If they click that link, we just go off and do a Bing search for finding our pizza shop. Let's say we're on dominoes.com.au and we were building this. That would just go to a list of all our stores. But what I want to do is when the page loads, we're going to put in some custom behavior. So I'm going to put an ID on the link. And say when they click it, let's go and run another function. And the first thing I want to do is just prevent the default action so we don't browse through to that other page. So if we refresh this, now when I click the link, nothing happens. Cool. So next thing I want to do is I just need a way to write our log message. So I'm just going to do a function. And all I'm going to do here is build it into an LI. So I just create a new LI element, set the text of that LI to the text that gets passed in, and then append that to location updates. So now when they click that link, we can just say we're searching. Click the link, searching. All right, so there's all our boilerplate code. I don't like to have a lot of smoke and mirrors, so you can see exactly what we've written there. So how do we actually go and get the user's current location? Off the navigator object, so this is a core JavaScript object, I can go navigator dot, and there's a new geolocation object. So this is a fairly new standard. It's not adopted across all the browsers yet, but I'll talk more about that as we go. And I can just say get current position. Now, one of the things about geolocation and going and gathering this sort of data from whatever mechanism you're using is it's never instant, well, unless it's static and you've got it pre-configured. So none of this comes back straight away. We actually get a callback. So I'm going to jump in here and have a display location function that I define. And we'll define that down here. And what happens is when we get the location, it actually passes in that as the parameter there. So we'll just log that out. And you can see here that off the location object, it's got coordinates as a separate property. So you could, there's also actually a .civic property, but that's not implemented in most cases. So now what happens when I go and click Find Nearest Store? What I'm going to do is save this as another page. Okay, and what we get here is a permission prompt that comes up. So the browser is saying that this site wants to track your location, and it's got an allow deny button. It's getting a little bit confused here because we're just serving it off a file. Normally that would say mysite.com or whatever. So if I go and click allow, that should go out in the background. You can have a race of the browsers. There we go. Firefox wins. There's actually a member of the Firefox core team in the back row, so he'll be happy. So what this has actually done, so here we go, we can ditch Chrome and Firefox gets a #1 spot for the rest of the talk. So it's gone and got our latitude and longitude. How did it actually do that? This is the really riskier part about where I do this talk, is it wholly depends on where I am. Because the way it's actually done it on my machine is based off, luckily, the very small number of wireless networks that it can see near my machine. And it's using Wi-Fi signatures. So if we jump into About Config in Firefox, and we have to promise to the browser that we'll be careful, and then I can go to Geo. There is actually, what you'll see down here, there's 3 properties. There's geo.enabled, and you'll also see a geo.wifi.uri, and that's going out to Google location services. So in this case, what Firefox have chosen to do is they've written a stack that goes and gets the Wi-Fi signatures for an operating system. They send it up to Google. Google don't know what web page you're on. They just know that you're in Firefox. Google sends the location back, and then they pass it to us. Now, that's just Firefox's implementation. As a developer, we don't really care too much, though. All we care is that we've got this nice abstracted API where we can go and ask for a location to come back. What's actually interesting, if you jump into C, program files, Firefox, components, there's a JavaScript file that actually gets installed, GPSD, geolocation provider.js. So this is one of the files inside Firefox. GPSD is GPS daemon. It's a Linux component that allows you to take a GPS. So the browser can talk to that on Unix platforms. They just accidentally install it on Windows as well. All right, so how can we do a bit more with this? The other thing we can get into is obviously sometimes the location won't be available. So if I provide a second callback, I'll say location error. And we can have another method. Now if I go and refresh this page and I say, no, I'm not going to share my location, the website gets all sad at me. Nice and simple. We can also go and pass in some options off the end of it, which can be quite useful. So what I'm going to do is, first of all, set a timeout. Because if all we're trying to do is help the user find their nearest pizza store quickly, we don't want to spend 15 minutes waiting for that data. So we can actually just set a timeout, and I'll set that to, say, 500 milliseconds. And now when I go and hit it and I go share location, there it hasn't got it in 500 milliseconds. So again, we get an error back. So let's make this code a little bit more robust though. I can take in an error parameter on my error callback here. And I can switch on the error code. We can also tell if the user denied permission. So then we could display a message explaining why we would like them to do it. And the other one is sometimes we just can't get that information. Unavailable. Yes, I can spell. And then we can always just fall through with our default. So now when I go and refresh this, if I hit the link and say don't share, we get not allowed. If I hit it again, share location, better wind the timeout down. Let's see if we can do it in 0 milliseconds. Ha, it can. And this leads into the next part of the talk. This is why I like to do the first part in Chrome, except in this case Chrome's losing. Exactly, it's cached. So what we can actually do is I can also set a maximum age. Watch this now. Let's see if we can get in 0 milliseconds with a cache that's... Okay, it's maintaining a link. Yeah, so Firefox is obviously still sampling my Wi-Fi signatures and seeing new Wi-Fi networks. Yeah, because there's other ones showing up. So one technique that is quite useful is you can actually, it's perfectly legitimate and discussed in the spec, you can set a maximum age and then you can set a timeout of 0. And what that says to the browser is if you have something in your cache in the last X number of milliseconds, tell me. If you don't bother going and look it up. So that's what I'm doing there. If it's got something in the last minute, give me that data. Otherwise, don't look it up. And then the last one that's kind of interesting is enable high accuracy. And this is a little bit wishy-washy. It basically says, try harder. Doesn't define what that means. It's totally up to the browser. It's not in the spec because the spec doesn't care how it gets the location because that's up to the browser. And it gives you no sense of what high accuracy really is. So this is actually quite a, I don't know, in theory useful property because it allows you to control power levels and stuff like that, but it's not very well designed. So last little bit to this is what happens in different browsers. So we've seen Firefox. I'm actually going to jump back to Chrome, and I'm going to set the timeout to 5 seconds. If I hit this, I need to clear my approval. So when I hit the link, there we go. It's going to ask me and 2, and 3, and 4, and 5, and it will go too long. That's a bug in Chrome. The time waiting for the user to give authorization or not shouldn't count. So Chrome loses 2 points. As more than just picking on Chrome, though, this is quite new, so expect to find a few bugs along the way, is the point. So here's the one I'm sure you're all waiting for of what happens when I put it into IE at a Microsoft conference. And I click the link. Well, first of all, it's giving me security warnings about my script and ActiveX controls. I click the link and I go and get a JavaScript error. So no, this doesn't work in IE. This is 8. But it might not work on lots of different devices. And the critical thing is, even if you do have this API, you might not be able to get the user's location. So we've already gone and coded to support, well, what happens if we don't get the location? But the other thing we can do is, through the wonders of JavaScript, it's very easy for us to go if type of navigator.geolocation is not an object, then what we can do is we can go and log no geo support and return out of this function. So now when I hit that link, we can know straight away that the browser doesn't have geo support. It's very easy for us to detect that. We have to build a UI that handles not having a location and asks the user or gives them an alternate mechanism. Do that anyway, and then you work across every single client. So we've seen Firefox, we've seen Chrome, we've seen Internet Explorer, and then the last one I'm going to show in the Windows Phone 7 track, this is my iPhone. This is the last time you'll see it. In Google Maps, so this is in mobile Safari, you'll see once it loads, in the top left-hand corner, we'll actually get a button that has a little dot on it. There we go. If I go and hit that button, this is like one of those Surface demos where they just keep touching it. There we go. Maps.google would like to use your current location. So it works in mobile Safari as well. And then that same sort of experience, it'll go and find, there we go, bam, I'm in Auckland. And in that case there, it's actually fired up the GPS. All right. So it's worked in Firefox, it works in Opera, it works in Chrome, it half works in Safari, it doesn't work on the desktop, it does work on the mobile. And so far, there's no evidence of it in Internet Explorer 9. However, they don't announce features in the builds until they're ready in prime time. You'll see shortly, I'll go into some of the Windows 7 stuff that actually shows, well, right next, why it's kind of a logical step for Internet Explorer to do that soon. All right, so now that we're at a Microsoft conference and I've shown Firefox and I've shown Chrome and I've shown an iPhone, the rest of the talk we're going to jump into Windows stuff. But hey, I pimped Visual Studio, right? So here I am. I'm going to jump into gadgets. Does anybody remember the sidebar from Vista? They're still there. There's just no sidebar anymore. I actually do kind of use them sometimes, particularly the currency one, just because of traveling a lot. But the other one I'm going to go and drop in here is the weather one. And you'll notice that it's sitting there for a second and kind of looks like it's frozen. But what's interesting, ooh, that's not very good. Talk value number 3. All right, let's fire this up a different way. we're kind of right on the cusp of where, now we're in the UK, we're right on the cusp of any Wi-Fi networks here. So it's having an absolute struggle picking up my location via Wi-Fi. All right, let's drop the weather widget on anyway, and I'll explain what it's meant to do. This worked perfectly in the speaker room or my hotel room, by the way. Do you reckon we could fit all maybe 150 people in my hotel room and we can continue this talk? Oh, there we go, Auckland NZL. So the weather widget there has picked up that it's really, really cold here. And it said Auckland, New Zealand. And if I hover over it there, it'll pop up a message saying, there we go, your location is detected. So what this weather widget has actually done is it's gone and used a stack that's in the operating system already in Windows 7 to go and fire up whatever location providers I had, kind of sound like the whole browser thing, fire up whatever location providers are there and feed it through to this piece of software. What I can also do as a developer is if you jump on to Codeplex and download the Windows 7 API code pack, this here is part of the sensors stack in Windows, you can go and write a .NET tool. This is an example of one. There we go. And what this is doing is this is using the same operating system stack, and then it's just getting the latitude, longitude, and displaying it in a .NET application. And if we zoom in there, it's... okay, it was reasonably accurate. I don't know Auckland that well to find our hotel. But it's, hey, it put us in Auckland. It's a good start. So how is this actually working? You will notice down in my tray area here, it's popped up a little icon saying your location has been recently accessed. If I double-click that, what we get is our sensors panel comes up. So this is part of control panel. The other way you can get to this is if you just hit the Windows key and type in location, it's the first option that comes up at the top. And here we have the ability to install a number of sensors. Now, by default, when the operating system ships, you don't have anything in this list. GeoSense is a free one that you can go and download. Just Google GeoSense, and this uses that same geolocation service from Google with the Wi-Fi signatures that we just saw that Firefox was using. And it provides that to the operating system. We can even go and say view location activity, and every time that this API is used, something goes into the event log where we can actually see what's been querying the location. So I can see the mapped demo there. I can see sidebar.exe, so that was when I dropped the weather widget in. And you'll even see Windows Live Photo Gallery has already got support for this. So this kind of leads to, it's sort of logical that sometime very, very shortly in Internet Explorer, we should also see geolocation support, because all they have to do is give us a nice little JavaScript wrapper on top of that. Now, when I was in some of those initial slides, I mentioned the idea of static location. Just ask the user where they are. With the Google Maps on the phone in particular, if it couldn't find my location, it actually pops up a dialog and says, or like a web page and says, enter your default location. The other thing that you'll see in this control panel here is down the bottom left, set default location. If I click into that, I can go and enter my civic address. Don't worry, I don't live there anymore. I moved about 3 weeks ago. And you'll also see there it's got a geographic location, latitude, longitude, no data. It's a little bit annoying. You can't set this through the UI that's there. You can set it through the registry. Of course, every user is going to go and type their latitude and longitude into a registry key to make it work. But we can expect all this to improve over time. The core thing is the stack's there. All right. So now I'm going to get back into some more code, and we'll go have a look at Windows Phone 7. One of the things you might have seen if you've been following the Windows Phone story so far is that all Windows Phone 7 devices have a series of basic hardware requirements. So if they have to have a camera and they have to have this much CPU and so on. And one of the things that's in there is some way of gathering location. So what I've got is, this is Visual Studio 2010 Express for Windows Phone. And I've got a copy of the emulator already up and running. I'm going to go New Project, create a phone application. If you believe the file name it just suggested then, this is the third Windows Phone application I've ever written, so you should be able to do this too. What I'm going to do in the grid here is just chuck in a list box, because I want to be able to write out a series of updates again. And then I'm just going to jump into the code. There we go. When this loads, I'm just going to set that list box to subscribe to that collection, and now we can start writing stuff out. Okay, so that's all my UI plumbing done. I need to add a reference. There's an additional assembly which you'll find under system.device.location, and I can now get a geo-coordinate watcher. So if I add the using statement for that, and then this actually gets quite simple at this point. All I need to do is just say when the position changes, so I'm just using an anonymous delegate here, but otherwise it's a stock standard event. As soon as I actually put my lambda in. And then all we've got off here is an e.position. So I'm just going to, in my updates, and then the location one, I can write out the is unknown. Actually, we'll make that if the location is known or not. And then we can also write out, if we go off the watcher, we can pull the status on the watcher. Okay. So if I just hit F5 on this, it'll build my app, it'll deploy it into the emulator for us. We've got our page title. Okay, and it hasn't done anything yet, because the critical step is you have to tell the watcher to actually start. All right, and what this is doing here is we're getting the behavior of, on a regular basis, it's going and sampling and trying to get that data. In this case here, though, running in the emulator, you just don't get any data. So you can go and write your application to use this, but obviously that doesn't work very well in a developer experience. Let's look at some of the other options that we actually get in here. I shouldn't have stopped that. Let's run this up again. Off the watcher, okay, this will be fun. Oh, there we go. You can see here that the desired accuracy is set to low. This is the same as the browser bit. Your accuracy levels are low or high. Cool. What does that mean? In a competing phone API, they have 5 different levels based on whether you want sub-meter accuracy, nearest street corner region, so on. I'm sure better documentation for this will come over time. It's just not there yet. You can also see a movement threshold. So this is a property you can configure. And when you have a location data that actually feeds back to you, what this means is in how many meters does the person have to move before it'll send you another event. In this case here, the permission is actually denied. The emulator is always permission denied. When you're running on a real device, the user has the choice to turn on the location stack on the phone on or off. So you can actually go and check that permission. And if you don't want to subscribe to the position change event, you can also just go and pull the position straight off the watcher itself. And it gives you the location object and the timestamp there. If we look at what's actually in the location object, we get all the usual stuff of altitude. We get the course, so that's their direction of travel. The horizontal accuracy in meters, so you can get an idea of that, whether or not it's known, lat, long, speed, and then vertical accuracy. So one thing you'll notice is that you don't get orientation out of this API. That's a different thing. So from our developer experience, how would we actually go and write some code that we could go and test this with and whatnot? Geolocation watcher, if we, Express. If you look at what geolocation watcher implements, it implements a system.device.location.iGeoPosition watcher of T, where T is geo-coordinate. The idea being that you could have different watchers that return different coordinate types or civic types and so on. Being an interface that's already there, this code is perfectly mockable, and there are a number of frameworks already online that allow you to either mock this for unit testing purposes, so there's some nice helpers around that, or the ability to actually go and replay stuff like recorded GPS plots into it, or even just feed out random data. So, but the key thing is that they've gone and put an interface behind it all so that you can interact with that. So that was a whole lot less code in Windows Phone 7 and nicer IDE support, obviously, than writing it in the browser as well. All right, so we've written some JavaScript. We've had a look at how it works in the operating system. We've written some code for Windows Phone 7. iPhone, you've got the mobile support in the web side of things, or there's also native support. And on the Nokia platform, the browser that's on a lot of the Nokia phones, the richer devices that have the color screens and so on, they support the JavaScript API that we saw as well. So there's fairly ubiquitous support. Right, so now that we've kind of got all this location data, how do we actually make it useful to someone? One of the first things is, if you think about something like doing a search for the nearest pizza store or something like that, or Foursquare actually do this really well if you use Foursquare, or when you go to do your check-in, you'll see at the bottom of the screen it says searching for venues near, and it says the address of where you're currently at. Now that's really useful so that the end user knows that you're actually searching in the right area. All this Wi-Fi stuff's great until you sit in an airport lounge. I was just over in the US about a week and a half ago. I was sitting in San Fran Airport. As an American Airlines plane pulls up. American Airlines have GoGo in-flight Wi-Fi in all their planes. My laptop knows the SSID, automatically connects, off we go. Anyway, I then posted a tweet, and my Twitter client decided, okay, I'll pull in the geolocation data, and it said I was in Boston. So then all my friends are going, what the hell are you doing in Boston? It's like, I'm not there, I swear. So you can't necessarily trust that data, and you want the users to be able to react in some way. The problem with it, though, is if we go and pull a location like this, so this is what we might get back from resolving the location, we really want that to say Dunedin to the user. This one was Dunedin. You got Wellington right at the start, though. But what we actually get back for that latitude and longitude is this address, which is all kind of really precise, but it's too much level of detail. We need to zoom that out somehow. And the easiest way that you can actually see this is if I jump onto a mapping product. Doing it in here just because Bing doesn't release their geolocation stuff through the UI. Bing releases this through the API. In Google Maps, if I right-click on something and say, what's here, you can see it goes and gives me the address really specifically. So that's reverse geocoding. How can we go and improve this actual data, though? So what I want to show next is a thing called WOIDs. So these are Where on Earth IDs. This is a proprietary data set, and I'm going to show you the API for it. But A, the data set's interesting. The other part, though, is obviously the concept. You don't have to use this data set. So in this case here, I'm going to jump into Firefox, just because it displays XML nicely. And one of the really interesting APIs that I find around is actually Flickr. They've got some of the best geolocation APIs out there. So I'm going to go and put in that latitude, longitude, which is 876,819. Yep. And the longitude 170. So this here is just an API test harness, so I don't have to actually go and build all these calls myself. And you'll see what it's returned here is a little bit of XML. So it's resolved that location, not as the really specific street address, but as some sort of civic concept of just an area or something. And we can see that it's resolved it as an area within Dunedin, which it's identified as a place type of neighborhood. What we can actually do, though, is we've got this really interesting number here, the WOID. These are a Yahoo-issued ID. They're reliable in that they never disappear. So if a WOID gets deduplicated later or something like that, the same ID will then remap to the new record. If that place is found not to exist or something, it won't get deleted. It just gets rolled up into its parent. It's a bit of a hierarchy, which I'll show you. So we've then got a REST API where we can query some more information. So we put in a place ID, and then you have to feed up your app ID. So I'm going to put in that place ID. And now what we get is a bit more information. So we can see, again, it's a suburb, we can see the name of it, we can see the country, region, county, everything it's in, all these different localities, centroids, and so on. I like to joke that this one down the bottom is a popularity rank. I don't know if anyone here is from Dunedin. 0 actually means no data, it's okay. Cool. So if we jump out of that, I didn't want to close that link. There we go. The next thing that we can actually do with these is, well, what if we want to get some sort of concept of what does this sit within? So we can go in the URL, just /belong tos. What does this area belong to? We can see out of this, we can get a whole bunch of different places. We get the postal code that it sits in, 9011. It's in Dunedin City, the region of Otago, tells us it's South Island, time zone Auckland, it's in New Zealand, Australasia, Oceania, Asia Pacific. Doesn't bother telling us what planet we're on. WOAD ID 1 is Earth. So how does this actually become useful to us though? What happens if I'm in my pizza app and I want to search for a pizza in Long Beach? So I'm going to jump in here and go places, and I'm going to search for an area called Long Beach. And funnily enough, it ends up as Long Beach, California. Everybody who's on the other side of the planet, Australia, New Zealand, I'm sure we're both the same. We get really annoyed when all the results come back as California. What we can do with this information is we can actually put a focus onto our query. So what I've done here is, in this particular API, I supply the focus parameter as a WOAD. But then what we get back is we get the town of Long Beach that's near Dunedin. And we go and get the latitudes and longitudes for that. So then we can start searching for a pizza store near that location. So this is one example of a data set, but basically taking the idea of getting a latitude, longitude that you get from a device, resolve it back to something that's useful to a user and say, I'm searching for pizza stores near Dunedin. And then when they go and actually type in the name of something, use these data sets, and there's lots of different data sets like this, use these data sets to actually improve those search results. This is particularly useful when you end up, particularly if you're taking plain English searches as well. There's some really interesting towns around the place. Particularly in France, they like to use a lot of common English words as town names. You can see how these would just screw up any type of query that you wanted to search. It's obviously Italy, and we've got India, and this one's in West Africa. All right, so we've gone and we've looked at how do we actually load location. We've looked at how do we make it useful to end users. How can we then actually go and sort of share that information as well? And one of the things that's really good about location, as much as it's new to a lot of the development platform, the database guys have been talking about it for years, but on the front end, we're just starting to care about it. But one of the things that's really good about it is there's lots of formats. Please don't invent any more. We've got an HTML micro format. So let's have a look at that. If I jump back into Visual Studio, just going to create a new HTML page. This page is pretty simple. It says, I'm from Sydney. Not a lot of information there in a computer-structured way. What I can actually do is wrap that in an abbreviation with a class of geo. I can put a latitude, longitude in it. And now when I go and refresh that, you'll see that micro format has been detected by what's a plugin I have installed in the browser in this case called Operator, where I can go off that and I can go and map that straight away. Now, other systems such as search engines or any of those sort of meta systems that are out there can actually go and pull that information out of my pages as well. So say you're building a local government listing or a restaurant listing or something like that, there's really nice ways of encoding this into your markup that'll then go and light up the browser as well. And that's nice and publicly standardized too. GeoRSS is a series of extensions to RSS that gives you a common way to put latitude and longitude in. Also GeoJSON. KML is Keyhole Markup Language. Before Google Earth was called Google Earth, it was built by a company called Keyhole. They were also responsible for a bunch of satellites that took all the satellite imagery. They're the company behind that. Keyhole Markup Language is an XML format for describing a whole series of points. How is this useful? I do a lot of travel, and I like to be able to share where I am. So I have a web page that's just on my personal domain name, so it's just Tatham/where. What this does, as soon as you hit that URL, high performance, waiting for the DNS. There we go. It's gone and found a map, and it's got my last 50-odd locations. So you can see I've been in Sydney, Gold Coast, I'm here in New Zealand, and I've been up in California. And these locations fade out over time. So how do I actually go and gather this data? I don't want to go and input this every time. Every time I tweet, I have my geolocation associated against it. I've already got the data set. Then when I went to build this page, I thought, well, I don't want to have to go and build a UI for it. So what you'll see up in the search box at the top there is actually this KML feed. So all I did was build a system that would go to my, as soon as you hit this URL, it goes to my Twitter feed, pulls the 250 most recent tweets, and then returns it as a whole bunch of KML with all the wrong line endings in it. So then all I need to do is just plug that into any mapping platform, which Google, I can do it through the UI. You just put it in the address bar. Bing, you can do it through the API. If I was to write JavaScript, new Bing map, give it the KML feed, it'll bring it up. Or the other thing I can even do is, if I go into Google Earth, I can go File, Open, I can put in that KML location, and all of that same data will get replotted into this client as well. So you see it's going to spin around the world and zoom in on, no, I haven't been to Africa. Okay. That's all right. So we've had 3 points down against Chrome and 1 against Google Earth. The key point being here, though, that I don't need to go and build all these different clients. There are useful formats for sharing this information. EXIF data, when you go and take a photo, this could be interesting. Let's open my private photo collection. There we go. So here's the car I was driving around in last week. If you go into the details of a photo, you've got all the data in here of what camera it was taken on, what f-stop, and so on. That there is called EXIF data. This information, though, there's also provisions where a camera can include the latitude and longitude data. Now, it doesn't show up in, oh, there we go, actually it does. So Windows here, you can see it's showing against this photo. It knows exactly where that photo was taken and what altitude, just embedded in that file. So what's cool about that then is completely transparent to me as an end user. I don't have to worry about doing any of this. When I go and upload that photo to Flickr, you can see on the right here, it says, this is a different photo obviously, this photo was taken this date, Sydney Central. So they've gone and it's plotted on a map. So they're using the latitude, longitude to plot it, and then they're using these other data sets to display a civic representation at a roll-up of the area where that photo was. The other interesting thing is in Windows Live Photo Gallery, they've actually got really good support as well. By default, we get it in date view. If you go up to the View tab up the top and then go Geotag, it's actually pulling out all my photos, taking the latitudes, longitudes, and then against a cloud service, going and finding how does it go and describe all those locations. So I can now go search my photos based on where I was when I took that photo. That's pretty cool. So that's EXIF data. One that's it was a little bit too early for its time, ICBM Meta. Back on the old forum days, people would post their latitudes and longitudes in their forum footers as the ICBM colon and the lat long. ICBM being a reference to intercontinental ballistic missiles. There's a bunch of nerds feeling like they were cool and militaresque and whatnot. That then continued into a bunch of meta tags that you can put in the header of your web page of ICBM equals, or meta HTTP equiv ICBM content equals. So you can describe what location a web page is about. And there are some meta geo services that have popped up that allow you to search web pages based on their location. And the final one is there's even a DNS entry. The same as you have A records and MX records and stuff, there's a location record where you can describe where a DNS name relates to in latitude, longitude. So we've got every format under the sun. Please don't invent any more. So today we've gone through what is location, geodetic versus civic. We've looked at how can we go and find it as far as what are the different devices and also how can we actually discover it through software stacks. we've looked at how do we make it useful for users in terms of experience. We need to think about things like location takes time to load. We need to describe it in civic ways. We need to allow users to override it. And we also need to allow users just to be able to supply static location if we can't gather it, or if they don't want to allow us to use other automatic ways. And finally, we've looked at how do we go and share location. If you want any of the other resources for this talk, they're all up on tath.am. There's a whole bunch of links up there. And there's, obviously, this has been recorded here at TechEd New Zealand, so you can rewatch this talk if you like at any stage. Thank you. Any questions at all? I'll be hanging up the front if you have any, or you can ask them out loud.